Example 3. Use graphing technology to solve equations and inequalities. Example 1. A motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour. The car travels at a rate of 60 miles per hour. When will the car be ahead of the motorcycle? So the first thing that we're going to want to do here is we're going to want to get an equation for the motorcycle and an equation for the car. So the motorcycle is 40 miles ahead of a car, and the motorcycle's traveling at an average rate of 40 miles per hour. So the rate of change of our motorcycle is 40 miles per hour, and it has an initial distance of 40 miles when we're starting this problem. So we get the equation y equals 40x plus 40. The car travels at a rate of 60 miles per hour. So the equation for the car is y equals 60x. Y-intercept is 0, 0 because at the start of this problem, it's at an initial position of 0. So we want to know, when will the car be ahead of the motorcycle? So when will the equation 40x plus 40 be less than 60x? Meaning, when will the equation 60x be greater than 40x plus 40? So these are really big numbers. We're going to use a graphing calculator to graph this instead of trying to make a table of values or scale this to easily graph using slope and y-intercept. So getting out our graphing calculator, going to our y equals, we're going to type in our first equation, 40x plus 40, and we're going to type in our second equation into y2, 60x. Now, I'm not going to hit graph, because if I just hit graph right now, I'm on a 10 by 10 window, and my y-intercept alone for that first equation is 40, well outside that 10 by 10 window. So what I'm going to do instead is I'm going to change my window. I'm going to leave the x min and x max because I don't think this is going to take longer than 10 hours to catch up, but I'm going to change my y min and my y max quite significantly. Since my y-intercept is already at 40 and I have a slope of 40 and the other one is a slope of 60, I'm increasing 60 every hour or 40 every hour. So I'm going to make this y max be something quite big, maybe like 200. We'll try that, oops, not 2,000, 200. We'll try that to start. And if I'm going from negative 10 to 200, I'm going to count by tens. So now I'm going to hit graph. So there's our first line, 40x plus 40, and there's our second line, 60x. So this is a great window. Obviously, we could have done better, but mission accomplished, right? We're able to see the intersection. So I'm going to roughly sketch this graph to figure out kind of what I'm looking at. So what I want to find is I want to find that intersection, that point where the car overtakes the motorcycle. So from my graph, I can calculate my intersection. So calculate is right here above trace. So we hit second, trace, and now there's our calculate menu. I want to calculate the intersection. First curve, right now I have the curve 40x plus 40 selected, perfect. Second curve, I have the curve 60x selected, perfect. Guess, I don't know why it asks you that. You have to hit enter one more time. And there we go, there's our intersection. X equals 2, y equals 120. So that point where the two are exactly at the same time and location is 2 hours, 120 miles. Which means that beyond that, our car will be ahead of the motorcycle. Looking at the graph, right, that pink graph is above the purple graph. So the car will be ahead of the motorcycle after 2 hours. And there's example 3, which is actually example 2B in your book. All right, example 3. Use a graph to solve the equation x squared minus 4x plus 1 equals x minus 2. Again, we're going to use a graphing feature for this. The reason why is the intersections do not turn out nicely. So the first thing we need to do is, just like our last examples, I'm looking for an equation where these two sides are equal. So we pull them apart to create our two equations. So we get y equals x squared minus 4x plus 1 and y equals x minus 2. So now I'm going to go to my graph in calculator, type in my two equations. So y1 is x squared minus 4x plus 1, and y2 is x minus 2. Now, I'm not going to hit graph, because if I hit graph right now, this window is still set up to go from my y values to go from -10 to 200, which is way bigger than I need for this example. I'm going to reset my windows back to the 10 by 10. So in order to set your window back, you hit zoom right here in the top middle, and then standard, option 6, just resets it back to that 10 by 10. So there's our quadratic, and there's our linear equation. So notice I have two intersections. So I'm going to roughly sketch that graph to visualize this, and I'm going to need to find those two intersection points, because those two intersection points are the solutions. The x values are the solutions. So second, trace to get to the calculate menu, calculate my intersection. Now, since there's two intersections, you have to be a little bit more specific when you're selecting your curves, so your calculator knows which intersection you're looking for. So right now, I'm going to find the intersection that is further to the left. So when I select my curves, I want them to be near that intersection. So right now, my cursor is right here at 0, 1, really close to that first intersection. So select my first curve, select my second curve, one more for good luck. There's that first intersection at -0.697. Let's go 3 decimal places, comma -1.303. To get to my other intersection point, second, trace. To get to that calculate menu, option 5 for intersection. Now I'm going to have to scroll my cursor closer to the other intersection, so that my calculator now knows I want to find the other intersection. So select, 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 and there's my other intersection. So we end up getting the two intersections, which means we end up getting two solutions, x equals 0.697 and 4.30.